Hi everyone, so in this video we're going to look at signals. Signals are sort of events, but they can basically be used to invoke code between different objects which don't have any relationship to one another. Signals are a good way or a useful way of avoiding having to define dependencies between objects, and they allow for a very flexible, almost message passing system. Some would disagree with how they're used. It's up to you to make sure that you use them properly. There are some caveats. They're not thread safe, and they are somewhat expensive to invoke compared to traditional methods. So if you can avoid using them, do so. But whenever necessary, they aren't too expensive once they have been invoked, because they just iterate through a list of their subscribers. It's only the initial invocation call that can be expensive. So what is a signal? Well, we're going to minimize our class here, and we're going to define ourselves class custom signal. And we're going to inherit from network.signal. Now, network objects can receive signals by default, and we'll explain how that works later on. For now, we're just going to pretend that we don't know about the base class needed to listen to signals, and we'll only work with network objects. So actually, all you need to do is define the class type, which is custom signal, and you have a signal type. And let's move it above our applicable definition so we can actually use it in our applicable class. And let's have ourselves a function which changes our name. Or in fact, we could actually we could run the change name RPC call in the client game if someone raises a change name event or a change name signal. So we're going to define an @ which is another decorator, custom signal dot listener. And this means whenever the custom signal event is invoked, we then invoke this function. Because we use listener and not global listener, this means you have to target this network object, this printer instance, in order to run this code. So let's say we've created ourselves a printer instance. So my_printer equals printer. And in reality, you would also have to give it a network ID, and you'd also have to update the graph, but forget about that for now. Then in order to change the name, you could either do myPrinter.changeName Angus, or your other way of doing it would be to take custom signal, and again, custom signal would need to update its graph, .invoke target invoke Angus, and target equals my_printer. And these two things are the same. The difference is really that you don't have to know what the name of the function is to invoke the function. You could have, change name could be called anything as long as the custom signal is invoked. In this instance, it's not particularly useful. That separation isn't that useful. What's more useful is when you have global signals, or when you want to have one function being run by many different types of signals. So let's say you had a function that would print out an exclamation, or maybe it would run some animation code that was to show surprise. But let's say that network objects could become surprised by more than one event, so either being shot or by being hurt. You'd have to write, if you did it the normal way, you'd define an onHurt method and an onSurprise method, and they'd both call the play animation code. Whereas this way, you can actually define another listener, so you could add another one on top of this, at custom signal 2.listener, and it would also be invoked for that signal. Now, this isn't, again, the most important behavior that the signal has. The main reason it's useful is that you can generalize a function call into a signal rather than knowing how it's implemented. So different people can listen for the same signal and do different things. For example, there is a signal that's invoked when a network object is instantiated, and for the network objects that might be useful to run a certain function, whereas on other people they might just want to collect information about who's been created. So having a general function call is a lot more preferable to having a specific function call in certain scenarios. Okay, so that's really how events work. So let's look at the different types of listeners. A custom signal.listener means that we have to actually target the change name function to be run on my printer instance. But if we had another signal, we could also run it as a general function. All we need to do is change .listener for .global_listener. Now, the interesting thing about this behavior is that because the RPC call will only be run for objects that own it, This would run on all. It would try and run the RPC call on all network objects, but it would be able to run them because it's simulated. So all network objects in the local game would be able to run this. But when it tries to send them over the network, it wouldn't run them on the client or the server because they're not owned by the client or by or the client connection on the server. So long story short, global listeners wouldn't make a difference here. It still wouldn't be run on any object except for the one that needed to run it. One example of a global listener is the update function. There's something called an update signal, and that's run on all network objects. And to use it, all you need to do is listen for a global listener function. The thing about global listeners is they can also receive information about context listeners. So if you invoke a signal and target a specific person, all global listeners will be invoked, as well as the specific listener that was invoked here. And that's something to be aware of.